think for the people that are presenting, George, Alexander, and Tim, I think, it'd be good if you guys could make sure that your audio is working. So maybe ask to do some audio, make sure you can speak and be heard. So I don't do that. You're very quiet, Alexander.
I'll try to check it. Okay.
Could be me too. Let me try.
Better?
A little better, yeah, that's good.
Okay. A quick question about the setup. Am I going to share my screen, or you will be sharing your screen and I will be asking next slide, please?
If you want to do yours, then why don't we try doing that now?
Okay. Is it working?
Looks like it's working.
Great.
Awesome. So then we can, just have you do your presentation when the time comes, and I can take care of everyone else's. Or yes, Randy. All right. 2 minutes over. Time to go.
I was just saying his screen worked.
Ah, thank you. Good. Okay. Hopefully my screen is presenting. Looks like it's working to me at least. If there's any questions or problems, let's make sure that they show up in the chat. Okay, so this is IETF 109 and the SIDROPS meeting at IETF 109. Welcome to Bangkok, sort of, at least Bangkok time. I'm Chris. There's Kayur and Natalie as well. I'm sure you've, of course, in this meeting already read the note well. All the materials are posted to the materials page, and ideally we'll have a Jabber scribe and a notes-taking person, which will pause here to collect. So does somebody want to Jabber scribe? Ah, okay, Natalie's doing the Jabber. Oh, Warren, do you want to take notes?
Oh, actually, hang on. Natalie says she's on. I'll do Jabber. Someone else can do notes.
Okay, Jeff is saying maybe we don't even have to do Jabber because we do it in the chat panel.
That's why I offered.
Oh, smart aleck. Okay, so now I don't know how this chat thing works. So many chat applications these days. Okay, I'm going back to Friendster. So it looks like Natalie and Kay are going to take care of notes. So off we go. The agenda is these 3 items: Alexander, then Tim, and then George. And then we're done. We have some spare time. So if we have a discussion about other topics we wanted to cover, we could do that in other business at the end. I think other than that, it's time for Alexander, unless there's any questions. Okay, I'm going to stop sharing, and Alexander, why don't you share your screen? Oh, sorry, Tim, do you have a question? If so, we can't hear you.
Yeah, can you hear me now?
Yes, go ahead.
So I saw my name on the agenda, but I don't remember asking for a presentation
okay.
on Sitel. So,
Okay, well, we have some slides that maybe they're not from you. Let me see what the slides look like.
but perhaps George
Right.
wanted to say something about it.
Those slides are from me.
Ah, okay, sorry. I'll change the agenda up. Okay, so not Tim, George, but right now, Alexander. So, and I'll change up the slides while we're chatting. Thanks.
So, do you hear me? Do you see me? I hope so. So,
Yes.
hi, hi everyone. I'm Alexander Azimov from Yandex, and here is an update for ASPA drafts. First slide. So I'm going to discuss some small but important changes in the draft related to ASP object profile. So previously, we had a good idea when we changed the profile from a pair, where we had a customer autonomous system and provider autonomous system, to a map, where we have customer autonomous system and a set of providers. At the same moment, I added a statement to the draft that there must exist only single ASPA record per autonomous system. And the statement was not that good because, first of all, it was not very realistic, because at the moment of object transfer, you have a problem. So the wording have been changed, and now the draft says that it should be a single project, a single object in every, not in every, but in the selected registry, and the registry should enforce that there is a single object for a pair autonomous system and address family. And the second part is that the draft also says that if there are multiple records in different registries, the object should be just the same. So it's rather simple, but it solves the issue that was in the previous version, and doesn't we will still be able to avoid raw-like synchronization issues, plus there will be no security flaws at the state of object transfer. So we got back to raw-like verification, pair verification process. So we're retrieving cryptographically valid ASPs, selecting its values, create a set of candidate providers. And after that, with this set, we are checking if the second autonomous system is present in this set. If it is present, it's valid. If it is not present, it's invalid. And of course, if the set is empty, we are not able to provide a proper check, so the outcome is unknown. I hope this part is rather simple. Second part is about verification procedures. And we have two verification procedures. One for prefixes that are received from customers, peers, and RS clients. And the second one for the prefixes that are received from providers and route servers. In the previous version of the draft, I introduced what I believed was a wonderful ASCII drawings. Unfortunately, from the feedback that I got, they haven't improved readability. I tried to improve them, but I failed, and I decided to remove them and replace them with pseudocode. This pseudocode looks like a Python code. And I've also worked on removing ambiguity in the wording, such as segments, paths, and special thanks here goes to Jay Bockenhagen. But before jumping to the formal procedure, I'm going to present you some drawings. And so, as I told you, there is no drawings in the draft, so you will have kind of unique experience. And here are the terms for the drawings. If you see a circle on top of another circle, this means that the circle on the top is the provider, the circle, or at the bottom. If you see two circles on the same level, it means that they are peering with each other. And most important part, arrows. Arrows stand not for the direction of route advertisement. It stands for the direction of ASPA check. So I hope you will not be confused. Let's move to the example. Here is the example. At this slide, we see an example of processing prefixes that are received from upstream path. As we discussed, upstream path is a prefix that is received from customer, peer, or a REST client. In this example, it's peer. So the wonderful thing about this kind of prefixes is that ASPA can consist only of customer to provider pairs, customer to provider, customer to provider. If we see there something else, it's a leak, and so we can detect it. How it works. We apply verification procedure for a pair 1, 2, valid, 2, 3, valid, 3, 4, valid. So the outcome of the check will be valid. It's clear. On the right side, we have an example of detectable leak. The procedure starts just the same way. We have 1, 2, valid, 2, 3 is invalid because the second autonomous system haven't authorized the autonomous system number 3 to advertise its prefixes to its APA providers. So with ISPA record from autonomous system 2, we will be able to detect this kind of leak. We can detect both by 4 or by 5. And now the formal procedure. It's just a quote from the draft. And so because this working group is working with this draft, I believe we should read it and agree on it anyway. And of course, it's way more complicated than the previous drawings because it needs to cover corner cases. So the first point stands for empty IS path. If the IS path is empty, the outcome is invalid. The second point checks whether the last autonomous system in the path equals to the neighbor autonomous system. If it is not, it's again invalid. Number 3. It's a most important and hard to read, but still easy to understand point. It just looks for a pair of unequal IS sequence segments that have invalid pair verification outcome. So it's just not a customer to provider pair in the IS path, but because of IS sets and so on, it's rather hard to read. The fourth point processes independently IS set segments, and the fifth point is nearly the same as the third one, and it processes unknown outcomes. And if we reach point 6, this means that the path is valid. Okay, and this was an easy part because we are now going to a verification procedure that should be applied on the prefixes that are received from providers and route servers. The key difference here is that the first pair that is invalid in terms of ASPA doesn't signal that it is a leak. It signals only the end of upstream part. And in a proper route, the upstream part may be followed by the downstream part. If it goes up again, it's a leak. I hope it's clear. And but we to verify downstream path, we need to change the order of in our check. So let's jump to the example. On the left side is the valid route. We are starting as we were doing in the previous one. So we're checking 1, 2 valid, 2, 3 valid, 3, 4 valid, 4, 5 invalid. But it's a downstream, but we are discussing here a downstream path. So it's a route that was received from provider and route server or route server. So the invalid 4, 5 doesn't mean that it is a leak, but it's the end of upstream part. And after that, we are checking not 5, 6, but 6, 5, 7, 6 to check that they are also customer to provider pairs. Hope it's clear. Now, on the right side is an example of a leak. It starts just the same: 1, 2 valid, 2, 3 valid, 3, 4 valid, 4, 5 end of upstream part, 6, 5 valid, 7, 8 it's not valid. It's not valid. It's invalid. So if we found a subsequent reversed pair with outcome of invalid after 4, 5, this means that the whole path is invalid, and so we detected a route leak. And here is a formal procedure. Normally, I try to avoid such kind of slides, but once again, it's important to make the drafts readable, and that's why it's here. It's a quote. It starts the same way as the procedure for the upstream path. So we're checking if the ICE path is not empty. If it is empty, then the outcome is invalid. Point 2, checks the last autonomous system in the path that it is equal to the neighbor with exception for access. Point 3, very important point. We're looking for the first invalid pair. So to detect the end of upstream path, and after that, we will be checking the downstream path. And of course, we need to store this indexed for the further check. Point 4, it's a simple one, point 5. Now we're looking for a pair, a reverse pair. This is also invalid. If we find this kind of pair, the outcome of the procedure is invalid, as we discussed in the example. Point 6. It's again processing wonderful ISET segments. Point 7. So we also need to distinguish unknown output of the verification procedure from valid. So in this case, we have 2 points responsible for this process. We have point 7 for the downstream subpath and point 8 for upstream subpath. And point 9, finally, if we are there, the path is valid. So this time for questions. My question to this working group will be about the readiness of the documents. At Yandex, we have evaluated for a half year the ASPA techniques. We use it in our monitoring tools, and we plan to start filtering using ASPA techniques prefixes in the mid of the next year. Unfortunately, we will apply this technique on very specific devices responsible for egress peering engineering, and I can't say that it will work in a majority of the networks. So to make it available for the larger community, of course, we need RFC and a lot of work with the industry. But first things first, and we need to finalize the documents, and I need your feedback about its readability and the special questions about Python code and so on. So my questions are done. The floor is yours.
I think George might have had a question earlier. Or not. I have a question. This is Chris from Google, not as a chairperson, but as a user. How do you verify, or how do you keep the IRR objects the same? Like early in the presentation, I think on the second or third slide, you said the ASP would point to a object or set of objects which are supposed to be the same, or could be the same.
So if
Single
you have, let me try to answer this question. So if you have multiple ASP records in different registries, you just need to keep them the same. It's not a registry obligation, it's user or signer obligation. Because ASP objects are not related to in rows you have an object where with prefix you are assigning a single autonomous system. In ASPA you are by your autonomous system signing, you can sign all your providers in one object. And of course there is no issues like more specific issues like in rows. So to avoid any kind of synchronization problems, just keep ASPA objects in different registers the same. That's all.
Okay, I guess maybe I misunderstood. You're not actually advocating double record keeping here. You're just saying if you happen to do.
No. It's just for the case that for some operation need, you have to temporarily run multiple objects.
Okay, thank you. Anybody else with questions?
Okay, if there is no questions, I will be waiting for some comments about and suggestions about the drafts, at least for a month. If there will be nothing, I will be asking to start a working group last call.
Okay. Looks like Job has a question in the chat.
Okay.
So he says, did you mean trust anchor instead of registry?
Yeah.
Okay. Okay. So
the wording can be improved.
Rudiger? I think Rudiger and Kayer both have questions.
Okay.
See? Yeah. Having the AS number from different trust anchors gets me into a strange state of mind. Having multiple ASPA objects from a single trust anchor is actually technically possible, because in the delegation chain, each CA that claims the AS number can do an ASPA. So dealing with multiple objects that semantically are overlapping seems to me to be pointing to somewhat strange cases in any way.
I think it was Randy in the mailing list who pointed that we cannot restrict multiple ASPA objects, but we can write in the draft that this kind of deploy should be avoided, and we can ask hosted systems of RPKI to make additional enforcements in their interfaces. I believe this should be enough.
Well, as far as thinking about multiple ASPAs along the delegation path from one trust anchor, one, I think, actually could do something like, well, the most specific assignment wins and the others are overridden, might be something one could consider. Having the ASPA out of multiple trust anchors is something that is not really allowed under the official certificate policy of the RPKI.
It's a very interesting comment, because I had a feeling that there is no restriction to create several ASP records in different trusted anchors at the same time. Is it incorrect?
I believe it is incorrect. The official policy of the RPKI says the CA resource sets are following the delegation tree. And the delegation tree obviously has only one trust anchor. And if the implementation is using multiple trust anchors that are overlapping, well, okay, not just overlapping by a claims all root certificate, but in fact overlapping in specific between several trust anchors for specific resources. I think that's indeed a problem. It might potentially occur in a documented way of the a procedure for transferring the AS number.
I believe I've seen something similar for rows, but I will double check it. Thank you.
Ben?
Hi, Alex. Ben from Work Online. So I think it's pretty clear that it's possible that we can wind up in a situation where an RP sees multiple ASPA objects and that is undesirable. But how are multiple ASPAs resolved together if a RP encounters them in the current draft? Is it a union of all of them, or is there some other algorithm?
It's just the union of all cryptographically valid ASPAs. So if we will have duplicates, it will be just fine.
Yeah. Okay. And the resulting union, the creation of that is deferred until a whole fetch is completed, right?
So this is the reason why we do suggest that do not list your providers in several records, but to list them in one record, because normally, as it happens with rows, and when you are getting the updates from with RTR, you will be once you have the record, you will not wait for others to come, and it's important to, that all this proper set of providers will come in the first single PDU. Duplicates is okay. Different records, not okay.
Yeah, I completely agree with the principle. I completely understand why that's the advice. But because of the presence of transfers and because of the presence of overclaims by the various routes, I think that we are going to see some instance where either because of a bug or because of user error, we need to deal as gracefully as possible with a scenario where multiple disagreeing ASPA objects are presented to an RP. And I think the best we can do in that scenario is just trying to avoid an outage as best we can.
Yeah, I agree. And of course, we can introduce some hacks here when we will, for example, as it was suggested in the mailing list for roles to send more specifics before less specifics. We can send first huge records for selected AS and then send small ones, but it will be a kind of hack.
Yeah, I to be honest, I don't think we need to go further than saying something along the lines of the RP should be relatively sure that it's completed a full fetch before sending anything. But yes, ordering it may be sensible as well. Anyway, thank you. I think you've answered my question.
So I see in the line Randy and Rudiger again.
Seems to be moderating the queue. I'll grab it. I think Rudiger is correct that as you come down from a TA, you use the lowest instance of a customer AS to be unique. I think in your early slides, I think you could have been a little clearer if when you talk about uniqueness, what has to be unique is the customer AS. But I think Rudiger is correct that you come down the chain and you pick the lowest one. The RP does know the chain. If she is following multiple TAs and multiple chains and comes up with multiple qualified ASPA records, I don't think you have a choice other than taking the union.
Okay. Thank you, Randy, for the comment.
Okay, my additional comment or question would be if you are talking about an RP that is fetching from several different trust anchors, I think you have to understand that kind of time is not a uniform concept between all of the different TAs, and saying you have a complete fetch for a certain state of the total system is just not possible.
I believe it was a comment to Ben's suggestion. But anyway, so I think we are on the same side here, and we're with the clear wording in the draft that suggests that in the selected trusted anchor there should be only single ASPA record, and if you have multiple ASPAs for some reason, they should carry just the same value. We should be fine. Okay, I don't see any more questions.
Okay. George, did you want to present for yourself, or did you want us to do that? Either works.
And either way, really, as long as you're happy for me to periodically say click, then why don't you do it?
Okay. Get back around to the right place where these are.
Yes, I'll start with Signtel. You don't need to see my video, do you? It adds nothing.
Yeah. Only if you want us to, man. Only if you want us to.
No. Hello.
All right.
My name is George, and I'm here to talk about the Signtel draft version 6. Click. So, to remind people what we are talking about, this is the mechanistic way that we could use in-band signaling so that relying parties could be informed in-band as they fetch data from the repository framework that a trust anchor is performing a key rollover. And the draft defines a reasonably straightforward information model, a new object called a TAC, a trust anchor key, and that is a declaration of the state of keys to be seen and whether they're in or out of use. And there's also the definition of the validation requirements to understand how a TAC is well-formed and valid. There's the request for the OID assignment, and there's the use of the .tac file extension in the manifest. And the draft also has examples of what key rollover would actually look like in a different range of scenarios. Click. So this draft has not undergone a great deal of change since the last time it was discussed. We added a paragraph to reflect on the feedback from Rob Kistelecki about the risks inherent in use of in-band signaling and the ability to steal a TA using this kind of mechanism. And we think that may actually represent the end state that we can get to in this document. So I just want to reprise why we're here. What do we think we're doing here? And our main purpose for presenting this work is about planned key roll. We understand from what Rob said about the mechanism that is often used, which is to preference vendor-backed updates. Vendors ship new TALs when they are ready to be deployed, and that then rolls out into the community at the frequency of update against the code. Our primary concern is that there are mechanisms that can come into play inside the CA framework, such as use of HSMs, that are unavoidably unable to export their key state if you move between vendors, or if you're performing a transition to something like the M of N mechanism that RIPE have had under discussion. These moments are unlikely to be ones that are particularly friendly to the timescale of asking people to update code through a vendor. We think a signal mechanistically would be a hell of a lot easier. And there's also this idea that there is a huge amount of deployed state inherent in the system. So people might be using Docker or other pre-built binaries. This actually is analogous to something that came up in DNS with 5011, and there was quite a lot of conversation about the need for appliances to be able to be taken off the shelf and understand signaling in system to inform them they were behind state against trust anchors and needed to update. So on the pro side, we think it adds functionality to improve the likelihood of convergence to the correct keys. But on the con side, there's absolutely this problem that it would add complexity to the system. So we think that there is this problem that is latent in what Rob said about malicious access to keys and a corruption of change through a Signtel. And we're thinking, well, if that really happened, the fallback mechanism here is to use the vendors to perform the community upgrade. We don't actually think the attack surface is largely increased because of an inbound mechanism, and we think we have a potential mitigation. Use the vendors. Click. So in our view, there is not overall a massive increase in security risk. And we like to remind people that all of the trust anchors are using HSMs. So theft of key is not just mechanistically about coming into this framework and being able to make someone believe attack exists. It's about theft of the rights of access to a protected piece of hardware that is fundamentally protecting those keys. However, there is the concern about complexity, and it would be foolish to pretend that we were necessarily going to get better security just because we added complexity. Click. So we, APNIC, have implemented a testbed. We've deployed a testbed which consists of a publication point with differing states of the TAC objects. So we have the single TA with a TAC that's declaring the current key, and 2 TAs with a TAC that says only the first key is active, and 2 TAs with TACs for both of them, but with a revocation event, and a single TA for a TAC, and the key has been revoked. And we think this set of 4 states should allow RPs that are developing against this to see all the potential varying states of being they could expect to ever see against a TA they had and a TAC. And we have, as well as publishing a testbed, we've got some example code that we've put into the public domain that shows how to use this. Click. So in deploying that testbed, it's likely that there's at least one more round of work based on experiences that have been gained from doing that deployment. So where previously we might have said, okay, this is one's cooked, why don't we push out? I think that it's plausible, based on what I've heard from Tom, who did the implementation, we're going to have another discussion about experiential behavior. And Tim has also noted that there are open areas in the draft, in particular, whether we should respect some keying limit and only ever encompass a single forward rolling key, or whether we need to encompass having more than one forward declared key. So there may also be other examples of test states that it would be worth looking into. And we think we should leave open the possibility that people want us to put into a testbed state different states that we could reflect on as well. So at this stage, we'd like to continue discussion on the mailing lists, and we think we'd like to aim towards working group last call in a future IETF. Click. I think that's the end of this presentation. Is there any feedback or comments?
George and the chairs, this is just an administrative comment that the chat in Meet Echo is currently not working. So people can't ask anything on the chat. Jabber is still working, and Meet Echo is aware of the problem and are fixing it. Just FYI.
That's entertaining. Does that mean I got off scot-free with no questions?
Tim has a question.
I'm sorry, I couldn't hear you. There was a terrible noise in my ears.
So I had a comment more than a question regarding the number of keys. So currently the document allows, well, X keys to coexist, and I think that generates quite a lot of complexity. And you know, it being complex to implement to begin with, it might be a impediment to you know, taking on this work. I think it may be simpler to just use 2 keys, and I think it would be enough for the use case envisioned. So that's where that is coming from.
Well, since we're not looking for closure, I think the best thing to do at this point is to carry this one forward into the mailing list and talk out the issues, and then bring up working group last call at a later IETF. There's potential here that we could actually see if vendor-backed key distribution is able to demonstrate closure in a small enough period of time that it covers 99% of the cases. And constructing complexity in a signing mechanism, if we can demonstrate that vendor-backed role is adequate, would be silly. So another approach here is that we open up some channels with RP vendors and actually start discussing how they want to be told about necessary code updates against TAL changes. And if that cycle is closing nicely, that would also be useful against this work, and we would bring that back to the room. I do think it's useful to document this kind of idea. I think there's merit in having a signing technique, but if it turns out that the community doesn't want to progress using inbound signaling to do this kind of key role, there's no point forcing it.
I think having it documented is worthwhile. I think relying on consistency of vendor implementation is yet to be demonstrated, and I'm with Rob on the security issues. This is Randy, IOJ Anarchist.
If there
Thanks,
is,
everyone.
I guess we'll skip to the next one, George.
Yes. Chris, would you be prepared to show the slides for my next presentation?
Certainly. 1 second.
Thank you.
There you go.
Hello, everyone. This is George, and I'd like to talk to you about the second draft of a non-working group draft on the RTA, or Resource Tagged Attestations. Click. So, this is a draft of a mechanism to implement detached signatures. We already have an OID that was allocated some years ago, so we are legal in the CIDR OID namespace as an object to exist in manifests. And our goal here is to try and define a mechanism that would work for business-to-business purposes standalone. The only requirement a relying party would have, apart from code that could understand the ASN1 and the validation process, was a TA. I've been told that Meet Echo has frozen. Can I confirm that with anyone?
It looks okay to me.
Okay, then I'll carry on.
It is working for me as well.
Okay, I will carry
Jabber.
on.
That's what you heard.
So, the kinds of context that we're thinking about here are validation, which are essentially the business-to-business private use where people are demanding proof of possession. So examples here would be bring your own IP, configuration formalisms, or letter of authority context. And these are typically outside of strict BGP. So they're not mechanisms where you necessarily want to make a public declaration. If you look at BYOIP, the current mechanism is using ROAs to try and signal proof of possession, but there actually is a problem potentially for some suppliers of service that they have to declare an ASN in order to let the user make a ROA against their prefixes going in to the state, but the ASN may not be the right one that's actually going to be used. So we have encompassed the multi-sign model, and the reason is that RPKI can create situations where a single entity may have more than one key over all the resources that they have to declare into use. So at the bare minimum, there's the potential need to have more than one key, even though it's only one entity who is using this mechanism. But we do think that there's potential interest in multiple entities who share resources signing business-to-business declarations. An example might be someone who's performing the function of aggregating lots of small fragments of address and is trying to demonstrate proof that they have a collective state that would be a covering less specific in order to create more value in the system. They'd need signatures from lots and lots of different individuals. The mechanism we're using here is based on CMS, and I'd like to again thank Russ Housley, who gave us great information on how to do things. Click. So there have been no substantial changes in the draft against the last version, but we've added some authors because we now have functioning implementations. We have two fully independent implementations. There is the APNIC code that was released some time ago, and we have funded work in NLNet Labs to implement RTA in Krill and Routinator. This is a compile time option, so it is not normally visible, but the great thing about this implementation is it's completely viable in a self-hosted environment. And if you read down, you'll see that there is also now a situation that 4 of the 5 RIRs support self-hosted RPKI. So you can already use the RTA mechanism if you have internet address resource under APNIC, ARIN, LACNIC, and RIBE. And there's absolutely no modification required in any RIR system to perform this function. So nobody has to revise their RPA agreement. Nobody has to consider the legal implications of allowing users to make declarations of any kind they like about their addresses, because this works self-hosted. And this is entirely private between you and whoever you wish to share things with a footnote that the keys you use almost certainly will be visible in the global RPKI, but the exact semantics of what you are signing in this detached signature, that's private to you. What do you want to sign? That's your business. Click. So, the only substantive question, apart from asking people to try out the Krill code and see what they think of this technology, is to understand if this work is interesting to SIDROPS and we should seek adoption in this forum, or if we should look in the community at large about provisioning of resources for future use in global routing or in business applications and find a different working group to pursue this work. Thank you. Click.
No more clicks, but there are 3 questions.
Randy, IJ, and Arcus. I think you're naive that some TAs may still consider that they incur liability, but that's their problem and the disease is bad. To be clear, we specifically asked for this for the geofeeds signing, to be able to sign a geofeed to have stronger attestation than how you found it. So thanks for pulling this back in. There are things I would quibble with, but we can take it offline. Thank you.
Thank you, Randy. That's very useful feedback. And I think you're right that it would be naive to imagine there aren't potential future risks. I think that's something that we will have, APNIC will have to discuss with the other RIR and understand how the community at large and the RIR feel about their risk exposure. We still see merit in this technology. We think it's useful, but I would be foolish to pretend there are not potential pitfalls.
Tim?
Yeah, so Tim Geisels, NLNet Labs. Let me state my affiliation for a change. Keep forgetting. Sorry, just a clarification, a small clarification. So this can actually work outside of the RPKI repositories in the sense that the CMS would be signed under existing RPKI CA certificates, but you wouldn't necessarily see these objects in the RPKI itself. So there might be use cases for that as well, but just saying it's not necessary for the validation between 2 private parties.
Randy, breaking in rudely, I would strongly suspect that these would not go in the RPKI, period.
So I think business to business pre-provisioning lies in that space where people actually want privacy. If I'm in a business negotiation with a range of CDN and cloud hosting companies, I don't necessarily want people to infer my future business intent. I've got a need for it to be private. I think where Tim and I are trying to feel our way is that we think the system has to be capable of working without visibility in the repository space, but we didn't say it was necessary that it never existed in the repository space. It's the join between the two states. If you're saying it shouldn't be in there, there is the potential need to understand the OID exists and objects could be created with an OID that's badged legal in this framework.
Ben?
Chris?
Ben, work online. So first of all, thanks for this. I think this is actually really, really useful. I was having an internal call the other day where we were talking about a problem that this would solve straight off the bat, and that we're having to currently work around using routing registry hacks currently. On the question of whether it should be visible in repos or not, I think there are use cases either way. I think, like you say, when it's a signal of kind of intended business dealings, then probably that wants to be private. But I think there are also use cases for this where people dealing with each other at quite an arm's length need to be able to communicate their intention. And for those purposes, requiring an out-of-band communication mechanism probably isn't very helpful, and being able to just retrieve it using the usual RPKI fetches is more convenient in that case. I'm thinking of scenarios where, for example, we have situations where
I think there's been a partial disconnection or other failure.
Yes, I think that failure was on my side. Can you hear me again now?
No, the Echo had to reboot a VM.
I don't know how much of what I was saying got lost.
It's fair to start over, I think.
So the short version, rather than repeating everything, is I think there are scenarios where being able to publish these objects in the repositories is helpful, and I think there are situations where it needs to remain private. So I think we need to cater for both use cases explicitly. But overall, I think this is very, very helpful. And I'd like to volunteer to be the person that bangs on Afrinic's door until that becomes 5 out of 5 RIs.
Thank you for that input. Thank you. Sorry about partial notes. If I've missed anything in my typing here in CodeMD, please let me know. Chris, I'm done. I'm handing back to you.
Okay, I think there's still Robert and Randy with questions, so you might not be done. Robert?
Yes, hi. I do agree with Ben that there is probably value in both being able to show and hide the actual signed objects that are hanging at the very end of the chain. But I do believe that the certificate that is used to actually verify those signatures should be in the repository. We have mechanisms. We have all the OIDs, we have all the mechanisms we need to actually put it in there and verify that it's correct and so on. So personally, I could see a way forward where the certificate, the end user certificate, if you will, is in the repository, in the manifest and everywhere, but the object isn't.
I think that's a valid model. We thought quite hard about deliberately designing not to need repositories, but the ASN1, if I remember it correctly, is capable of not having the full chain. It would be possible to only specify the immediate EE cert of use and depend on chain validation in the normal validated repo state. So I don't think that the ASN1 is going to preclude that model of use. It wasn't one we foresaw, but that doesn't mean it can't be encompassed.
Yeah, I totally agree. I do see the benefit of being able to delegate the full chain verification to the existing mechanisms already. So the only thing you really need to verify is the document itself and the signature on it. And you can rely on everything else being there already. End of message.
Scaling issues and garbage collection.
So the actual detached signatures themselves are reasonably small. If they contain a full chain of parent certs, they're not zero because they're not just the SIG and the necessary cert pointers, but they include cert state. But they're not inherently extremely large objects. So the part of this that is things do get into published repo state and have to be dealt with, I think it's at the low to tolerable end, and mostly invalidation of the cert chain above the EE cert would take care of it. Unlike previous models of arbitrary object where there was that problem of a denial of service risk that people might sign Star Wars Volume 6 and then upload it into the repo and do a massive attack on all the relying parties, this does not expect to ship the refereeing data. It's only the SIG component that is necessarily going to appear if it were to appear at all. So I think it's not dissimilar to a stale rower situation, Randy. Has potential to be garbage, but it's contained, but it's not a non-zero problem. And it might be worth actually noting that in the document.
Still Robert, or did you finish up, Robert?
I believe I finished, and I believe I'm not in the queue. Maybe I am.
Oh, it just shows in the queue for me. So, okay. So if there's no other questions, we're either done, or if there's other topics somebody wanted to bring up, we could do that now. And the chat's not working, so I guess we'll just wait for somebody to, a few seconds, or somebody to pop in the queue if they have any questions they'd like to, or topic they'd like to talk about. Tim?
Yeah, Tim Rijnsels, NL Labs. Yeah, Chris, I thought that in an earlier draft of the agenda that you wanted to speak to the rsync fallback discussion that's been going on in various places. So are you still planning to do that or not?
I had planned to, but I think it kind of closed itself out. I think the long and the short of the conversation was, at least from my perspective, that you know, we designed something, we built it, then we went to go use it in operations and realized, oh gosh, maybe it works differently than we expected, and we need to adjust our plan, process, procedure, and operations a little bit, which I think is a perfectly fine thing for SIDROPS to do. That's kind of the point of being here is, hey, this thing is not working as we expected. Let's go fix it. So.
Right, okay. Yeah, because I think there are two discussions that kind of got conflated. One is around what RFCs currently says that must be done. Another discussion that's perhaps much more useful is about what the best thing to do would be. And on that, we already said that we are willing to do the fallback and continue the discussion on the rsync deprecation as a separate effort. So maybe we don't need to say a whole lot more about it right now, but then I want to reach out to my co-authors on the rsync deprecation document now and say, okay, let's see if we then can start that conversation again and move that forward. That would be very, I would be very happy if we can.
Yeah, I agree with you that both the discussion got very widely varied and not particularly helpful at times. And that a lot of it, I think, does circle around how are we going to move away from rsync if that's indeed a goal. And my personal, not chair belief is that should be a goal. But
so as one of the co-authors, I believe firmly that rsync was something that got us to a useful place, but it wasn't ultimately the correct protocol to use. And I think Job has done a very good job of saying that the open apparent risks, the denial of service risks, the occlusion of data risks that lead inexorably to invalidation of significant subcomponents of the repository space just represent attacks on the system, which it would be stupid to keep. Moving to a TLS transport, moving to mechanisms that make that harder, no, they're not guaranteed to prevent all forms of attack. They close off enough paths of attack that I think they have significant merit. And there's the additional thing that I honestly believe the CDN benefits, the localization, the speed of closure to a bounded state against the deltas visible in the publication space. I think that it's a better protocol. I think RRDP on a TLS carrier is just a better protocol. Now, I know we're talking about signed data. I know that in principle, channel security should not affect the integrity of the data space we're talking about because all the elements are signed. You can know you're under attack. But the problem is the necessary consequence invalidation for people who are trying to perform decision logic in BGP. You're under attack. What the hell are you meant to do? At some point, if the attack persists, your validation state is no longer valid. Certificates have lifetimes. You're in a bad place. So I think protecting the integrity of this system, getting faster reconciliation and closure, moving to a protocol that's amenable to being put into a CDN is a no-brainer. But the problem is, it's a transition. And we're just crap, to use the technical language, at handling transitions in the IETF. But as a co-author of this draft, I put my hand up to get back in the boxing room for another round of chess boxing and try again.
Can I add something to that? Natalie Treneman, RIPE NCC, speaking now as one of the bunch of relying party providers that are out there. As you might have heard, we decided to discontinue work on our validator in July next year. And we looked at the amount of work that it would cost us to implement the fallback scenario from RDP to rsync. And we came to the conclusion that we cannot implement this in time. So we are not going to implement fallback. Instead, we are going to focus on our RDP being rock solid. And yeah, that's it from us.
Tim? Okay.
Yeah, no, yeah, I don't really have anything more to add to this, I believe, Chris. Tim runs as RIPE NCC, formerly RIPE NCC, and all that laughs. Muscle memory, I guess, tongue muscle. No, I would say let's move forward on deprecate rsync. We can have lengthy discussions about how we quote various parts from RFCs, but it's probably not all that constructive to do so. So I would say let's move forward.
Okay. Okay. That sounds terrific to me. Any other topics? Going once? Going twice. Okay. I think there's a couple of action items left over from the meeting here. One is it would be nice if Alexander could send a working group last call request. Can we, in other words, hey, can we last call my 2 documents, please, on ASPA? Please read them and make sure there are no comments or questions or unclear bits and pieces. Alexander, please send a mail. And I think, George, you also have an adoption request buried in your 2 slide sets. So it would be good to email that to the list as well.
I will take that.
Thank you. And I think that's it for today. See you all in at least 3 months, but if we need to do something in between, please speak up on the mailing list. We can always arrange interim meetings with, I think, 2 weeks notice. So thank you very much and see you at least in 3 months or 4 months, but whatever.